So, how does science make those big calls? How do we really know if a new discovery is a genuine breakthrough, or if it's just, well, random luck? That's exactly what we're going to break down today, the super powerful process of hypothesis testing.
I mean, think about it for a second. Does that fancy new fertilizer really make your plants grow taller? Does a new experimental drug actually save lives? How do we get from just a claim, an idea, to a conclusion we can actually stand behind?
Well, here's the thing. To find out, science doesn't just take a wild guess. It does something much cooler. It puts the claim on trial in a really specific and methodical way.
Okay, let's dive right into this. Welcome everyone to the scientific courtroom. This is the place where every new idea has to face the cold, hard facts.
And in this courtroom, it's not just one story on the stand. Nope. Every single new idea is judged against two competing possibilities. You could even say two different versions of reality.
And these two possibilities, they are the absolute heart of our trial. It's the null versus the alternative hypothesis.
I love how this frames the whole thing. On one side, you've got the defendant. This is the null hypothesis, or what scientists call H0. It's the status quo, the boring, nothing is happening here idea, the claim of no effect. You have to think of it like innocent until proven guilty. It's the default reality we assume is true unless we get overwhelming evidence to the contrary. Then, on the other side, you've got the prosecution. This is the alternative hypothesis, or HA. This is the exciting new idea, the research claim we're all interested in. It argues that there is an effect, a difference. And, just like a real prosecutor, it has the entire burden of proof.
Okay, let's make this feel a little more real. Let's say our big research question is, are men on average taller than women? The null hypothesis, our defendant, would say, nope. Men are, on average, not taller than women. See? It's the default, kind of boring assumption. But the alternative hypothesis, our prosecutor, makes the bold claim we actually want to test. Yes, men are on average taller than women.
So, we've got our defendant and our prosecutor. What's next? Well, every trial needs evidence, right? And in the scientific courtroom, that evidence is all about data and statistics. And the process for gathering it is pretty clear. First, we go out and collect data from a sample of people. Then we run a statistical test to analyze all that information. And finally, and this is the cool part, that test boils everything down, all that complex data, into one single powerful number. It's called a test statistic. Just think of this number as the key piece of evidence, Exhibit A for our trial.
All right, we've presented the evidence. Now it's time for the most important part of any trial, the verdict. And in the world of statistics, the verdict comes in the form of something called a p-value.
So the evidence is in. The arguments have been made. How does our scientific court actually deliver its verdict?
It all comes down to this one thing, the p-value. It's the probability of seeing the evidence that we collected if the defendant, the null hypothesis, were actually true. Let me put it another way. Just how surprising is our data if there's really nothing going on?
So, here's the crucial point. A really small p-value means our evidence is super surprising. It's just very, very unlikely if the defendant is truly innocent. It's like the prosecutor finding a piece of evidence that completely contradicts the defendant's alibi.
But, how small is small enough? Well, in most fields of science, the line in the sand, kind of like they're beyond a reasonable doubt, is a p-value of less than 0.05. What that means is there's less than a 5% chance of seeing evidence this strong if the null hypothesis were actually true. So, if our p-value drops below that line, the verdict is in. We reject the null hypothesis. The evidence is finally strong enough to support that new, exciting claim.
But hang on, listen very closely to the wording here because it's so important. We say we fail to reject the null hypothesis. We never say we accept it. It seems like a small detail, but it's a huge deal. It's just like when a jury comes back with a not guilty verdict. Not guilty doesn't mean the person is innocent, right? It just means there wasn't enough evidence to convict them. It's the exact same idea here. We just didn't have enough evidence to kick the old idea out. Now, before we wrap this all up, we have to talk about something that every legal system, including this scientific one, has to deal with, and that's making mistakes. Let's talk about the two types of error.
Because, let's be honest, just like in a real court, this system isn't perfect. It's powerful, but it's not foolproof. Sometimes the verdict is just plain wrong.
And there are basically two ways it can mess up. A type 1 error, that's when we reject a null hypothesis that was actually true. In our courtroom, this is the absolute worst-case scenario. We've just convicted an innocent person. A type 2 error is the other way around. We failed to reject a null hypothesis that was actually false. In court, that's letting a guilty person walk free. The whole system is set up to be really careful to minimize that first, most serious error of convicting the innocent.
So let's just quickly recap the key takeaways from our little trial here. First, hypothesis testing is a formal, structured procedure for looking at claims with data. Second, and this is a big one, it doesn't really prove anything. It just weighs the evidence against that default, nothing is happening assumption. And finally, the whole system is built to be cautious, to be conservative, always making new ideas do the hard work of proving their case.
So now you know the process. The next time you read some big headline about a groundbreaking new study, you'll know exactly what was going on behind the scenes. And you'll be able to ask the most important question of all. What was that boring status quo idea they had to go up against? And just how strong was the evidence they used to put it on trial?